Okay, so today I'm going to do 2002 question number 2. And again, if you are in the early number questions, it means it's calculator questions. So this one, when you look at it, it looks like a complicated equation. And the reason they do that is to make sure that you are forced to use your calculator to do this. So they really want to test on whether or not you can put these in your calculator. What they look for on the paper is very little, just some statements, some equations that equate one thing to the other. So, first of all, when you read one of these equations, note that it tells you the rate at which people enter and the rate at which people leave. So, bear in mind these are rates, not amounts. So, if they ask an amount question, you do not use the rates to find the amount. Second thing is you read through the problem, they'll give you other information. One of them at the very end says at time t equal 9, there are no people in the park. So that's important. Starts out empty. So when we do the integrals, there's nothing we have to add to them because there's no one there at the beginning of the time. So question or part A asks how many people have entered the park by 5 or t equals 17. And again, this is a calculator question. So all they're looking for is how you find the answer. The way that we find the answer for an amount, if we're given a rate, is by integrating. And we want to know between time 9 and 23, that's the time that this rate is what it is. So we're going to start at time 9 and we're going to end at time 17 for this question. So the integral from 9 to 17 gives us from the beginning of time to the time that they asked. And you do not have to write the equation down if they give you the equation. You just need to write down an expression for the equation. So they tell you the rate that they enter the park is E of t. So you don't have to write down the equation with all the values in it. You can just write that. And then because you're putting it in your calculators, there's no work to be shown. So 1 point is if you get the limits. So if you know from 9 to 17 and do nothing else, you get a point on this problem. The second point is to know that you have to integrate the entering rate function. And then you get 1 point for putting it in your calculator correctly. So it should be fairly easy to get 3 points just by writing this down. So how many people have entered the park? 6,400 people have entered the park if we round to the nearest whole number. So because it says round to the nearest whole number, just somewhere underneath, say 6,400 people. For B part, it asks you to find the price of admission is $15. The price of admission to the park until 5 is $15. After 5, it goes down to 11. So how many dollars are collected? Well, the amount of money collected is the price of whatever it is times the number of people that enter. So we have a price of $15. We have a number of people that enter. Well, the number of people that enter is just like we found in part A. So an integral from the beginning of the time, which is 9 to 17, which we've already done, you could just write down the answer to this one and they would know that it carried over. Plus, after that time, it's only $11. So the price times the amount of people from 17 to 23 of the function. Again, it's a calculator question. So you get 1 point for the setup and then 1 point for your answer. Again, it's a calculator question. So how much money was collected? Go back, it says to the nearest whole number again. So in dollars, we have this amount. C part says to let a new function h be the difference between the entering and the leaving the park, and the value of h to the 17 is given. Find the value of the derivative of 17. So we'll start out by saying that the derivative, of this function would be equal to the derivative of the integral, which was given. And the derivative of an integral is just the function. So it's just going to be e of t minus L of t. And then you plug in the 17. Again, it's a calculator question, so the only work they're looking for is you to write it down, put it in your calculator, and you get this value here. What does it ask you to, what does this mean? As far as the fact that it's negative, because it's negative, it means that when a derivative is negative, it is a decreasing rate. So the rate is decreasing. In other words, there are 380 people leaving the park at time, or the rate is decreasing at 380 people per hour at time t equals 17. So the number of people in the park was decreasing at a rate of 380 people per hour at time t equals 17. Again, when you answer that question, be sure that you put at time 17. Don't leave that part out. So at time 17, number of people is decreasing. 380.281, 81 people per hour. And then in D part, at what time does the model predict the number in the park is a maximum? Again, to find a maximum, we're always looking at derivatives, so we just set the derivative equal to 0. Again, it's a calculator question, so what we do is put this equation in the calculator and find zeros. So t would equal 15.794. If you are using a TI-84, put the function in just like it is here. So put the fraction minus the fraction, and then use your calculate button to find the zeros. There's probably going to be more than one. I haven't looked at the graph of this one. There's probably going to be more than one, but you have to find the one that's on the interval from 9 to 23. So we know that time has to be somewhere between 9 and 23. That's how we choose this one here. Now, I heard rumors that you're going to be able to use online calculators. If you're going to be able to use online calculators, you can probably use Desmos. And I'm not 100% on this. I'm hoping they send out some more information, and you may have already gotten it, to say what kind of calculators you can